Okay, so now what we're going to do is focus on writing the equation of the polynomial. And basically what you can see is we have a product of the factors. And that was basically our idea in our previous example, was to get to this point. But now what we're going to do is basically take the product of its factors and kind of work our way back up to the standard form. You can see here we have the writing of the product of the factors and going back up. So to go from standard form to the linear factors, we were applying the process of factoring. So to go from a product of factors back to the standard form, all we simply need to do is multiply our factors together. Now, some of these sometimes be a little bit more confusing or more work than others, but I think also if you can identify some patterns that we'll talk about, it can make it a little bit easier, as well as some techniques to kind of keep everything organized. So that's what I want to kind of go through on this video. Now, this first one, you're not usually going to see this as x minus 0, but I just wanted to kind of represent that, because that's one way that we kind of talked about 0, or 0 being a 0 of the polynomial. But more often than not, you're just going to see this represented as an x times x plus 1 times x plus 4. Now, it's important that we have a product of 3 factors here. Right? And it really doesn't matter which way you want to move. If you want to multiply x times x plus 1 first, and then multiply that times x plus 4, perfectly fine. Or if you want to multiply these two first, perfectly fine. I like to say I'm pretty familiar with multiplying binomials, so that's usually where I kind of start, because you can go through the FOIL method, or you can just applying distributive property, whatever way that you have learned. I usually like to do those because I can do those rather quickly in my head, because obviously I've had a lot of practice with that. But if you want to multiply the x first, that's perfectly fine. So in this case, I didn't do anything with the x. I'm going to multiply this one out just so you can see, and then future ones I'm going to kind of I'll talk it through my head, but I'll just write the answer. So x times x is going to be x squared. X times 4 is 4x. 1 times x is just 1x, or we can just write that as an x. And then 1 times 4 is going to be a positive 4. And again, the nice thing about this is since we have the same linear binomials, we know that our middle terms are going to combine here. I'm going to zoom in one more time. So therefore, we'd have y equals x times x squared plus 5x plus 4. Okay, now we can do distributive property one more time, and then multiply the x times everything, and we will get our final polynomial in standard form, which is x times x squared is x cubed, x times 5x, which would be 5x squared, plus 4x. Okay, there we go, and that's it. Now for this next one, I'm going to break this one apart, but when we get to ones that are similar to this, I'm going to kind of go through the kind of simplified process. So remember here we have x plus 3 squared, so that means it's repeated. It's x plus 3 times x plus 3. And please, just a reminder, this one, I've already talked about it so far in this course, but it comes up all the time. Please do not just distribute that squared and say it's x squared plus 9. Remember, this is a repeated. This is x plus 3 times x plus 3. So we're going to want to write it that way so we can do the multiplication correctly. Now, I will say that remember binomial squared, oops, let me just write that out. Remember binomial squared come from perfect square trinomials. So if you understand the pattern of a binomial squared and perfect square trinomial, you could kind of quickly identify this product, okay? And we can just go ahead and multiply that out by using distributive property like I did over here. But hopefully you should know binomial squared create perfect square trinomials, where the first term is a square term, the last term is a square term, and the middle term is 2 times the square root of that term. So I'm going to do that rather quickly here. I know that x times x is going to be x squared. 3 times 3 is going to be 9. And then if I remember, 3x and 3 times x, x times 3, 3x. So add those two together because they're going to combine just like how these two terms combined. The 3x and the 3x are going to combine to give me 6x. Okay, so now we have a binomial times a trinomial. And this is where a lot of times students get stuck with this because they start making mistakes. And there's a lot of different ways we can go about this. We can apply distributive property, which I think is just the way that, just like how we did FOIL. FOIL kind of has that nice little, acronym, first, outer, inner, last. But we can't do that anymore with this. So now we're just going to have to apply just writing as the distributive property. And basically, again, the distributive property is telling us that each and every term needs to be multiplied by every other term. Okay, so when I do this first multiplication, I'm just going to write it down below. So I'm not going to include this as part of my polynomial. This is going to be kind of like side work. X times x is x cubed. X times 6x is 6x squared. And then x times 9 is 9x. Now, when I do the next round of multiplication, I'm going to vertically align them. And this is just a way for me to kind of keep everything organized. So I have negative 2 times x squared. So I'm going to want to place that under this other x squared. So I'm going to have negative 2 x squared, because again, the x squareds are like terms, right? You can only add and subtract exponents that have the same base as well as power. Those are like terms. Negative 2 times 6x is going to be a negative 12x. And then negative 2 times 9 is going to be a negative 18. Okay, so now that I've vertically aligned them, I need to combine them, which is basically going to be adding these two terms. Now, this gets a little confusing for students because they're like, well, how are you going to do this when you don't have a purple x cubed? Well, you can just write that as a 0x cubed. What about if you don't have a red number? Well, then just use 0. Okay, and now we're just going to vertically add these, and when we vertically combine them, that's going to give our final polynomial. So x cubed plus 0x cubed is just x cubed. 6x squared plus a negative 2x squared is a positive 4x squared. 9x plus a negative 12x is a negative 3x. And 0 plus a negative 18 is a negative 18. Okay, so that works perfectly fine. There's nothing wrong with that technique and following along with that. Sometimes though, as we start getting bigger and bigger, like trinomials, trinomials, we might want to look at something that might be another easier way to kind of organize. Oh, I guess I didn't do it in this one. So we'll get to, or maybe I'll show the box method for this one as well, even though it's not really as necessary. You could do this one perfectly fine, but we'll talk about it. All right, so in this case, I have y equals 2x minus 1, x minus 2x plus 2. So hopefully you recognize that when you have binomials that are we call conjugate pairs, the one's positive, one's negative, but they have the exact same term, that is the difference of two squares factored, right? So, if we just go back and look at your examples from the previous lesson, you would see when we had those examples that were differences of two squares, right? X minus 4, x plus 4 gives you x squared minus 16. X minus 2x plus 2, x squared minus 4. So you can multiply them out if you want to, and if you don't recognize that relationship, fine, multiply these out. But what you'll notice is you're going to have a negative 2x and a positive 2x, which is going to give you 0x, which we just don't write. So I can kind of quickly multiply those out. Negative 2x minus 1 is going to give me a x squared minus 4. So you could go ahead and multiply this out. There's nothing wrong with that. I am perfectly fine with that. I'm going to show you another method. And that other method goes along the ideas of multiplying to find the area. So when we're multiplying, to find the width of the area of a box, we're basically doing the length times the width, right? And what I want you to kind of think about that is right here we're multiplying. You can kind of think about this as like length times width. Now these aren't numbers, right? It's not like 4 times 8 and you're finding the area, which is 32. This is, going to be expressions that represent the area. But that's fine, and these expressions are separated by two different terms. So what we're going to do for our box, no matter how many terms you have, you're just going to set up kind of rows and columns for the number of terms you have. So in this case, we have 2 terms times 2 terms. Sometimes it might be 3 terms times 3 terms. So you do 3 rows times 3 columns, or whatever your problem may be. Now it doesn't matter which one you represent as the length or which one you represent as the width, because again, like 3 times 4 is the same as 4 times 3, right? So I'll just represent the length over here. So I'll do 2x, or the width over here, 2x minus 1. And then here I'm going to do x squared minus 4. Okay, now what we're doing is we're doing length times width. So the product is going to give us this area of the rectangle. But that's kind of confusing if you're trying to multiply these and really conceptually understand the area of that larger, rectangle. So since the way of breaking it up by the terms as far as the number of rows and columns, we can just focus now on finding the area of each of these rectangles inside. Length times width, length times width, length times width, length times width. So, and then we'll just combine them all together to get our area of the whole rectangle. right? So 2x times x squared is going to be a 2x cubed. 2x times negative 4 is a negative 8x. X squared times negative 1 is a negative x squared. Negative 1 times negative 4 is going to be a positive 4. Now, the nice thing about the box method is when you do have products of binomials that have the same powers or in the same standard form, you're usually going to have terms that are going to combine along the diagonal. That is not the case in this example, but when we work on another examples, you'll see how that does work. So now, this is the area of the box. So now all I need to do is write that out, and I'm good. So therefore, I have 2x cubed minus x squared. I'm going to want to write it in standard form. You don't have to, but that's kind of the preferred method, plus 4. Okay? So there you go, ladies and gentlemen. That's basically what we need to do when we're given a linear factorization when we want to write it in standard form. So now we'll work on getting on to what about when we're given actual zeros from this point.